In this video, we are going to talk about the momentum. What does the momentum mean? The momentum means the mass in motion, the amount of mass in a state of motion. If we are talking about the momentum, this means that we are concerned about the mass of the moving object and its velocity as well. الدefinition بتاع المومنتم هو the mass of the object multiplied by its velocity. The importance of the momentum is that it gives us an idea about how difficult it is to stop a moving body. The more the momentum, the more difficult it is to stop the body. Okay? The more the momentum, the more the force that was needed to get it into motion. It means that it needed a very big force to get it into motion. This body which has a big momentum. Is the momentum a vector or a scalar quantity? It is a vector quantity that has both magnitude and direction. What's the unit that is going to be used for the calculation of the momentum? If the mass is used in kilograms and the velocity in meter per second, then the unit of the momentum is kilogram meter per second. This is equivalent to Newton second, and I'm going to prove this in 2 minutes. We know quite well that 1 Newton is equivalent to 1 kilogram meter per second square. If we multiply both sides of the equation by second, then the left hand side will be Newton times second, the right hand side will be kilogram meter per second square times second, which means that the 1 Newton second is the same unit equivalent to 1 kilogram meter per second. If I'm calculating the momentum, I can calculate it in Newton second or kilogram meter per second. Both are the same. Now, if we have a look at these two moving objects, this car having a mass of 300 grams and this truck having a mass of 3,000 kilograms. Which one, if they are both moving with the same velocity, both are moving with the same velocity, which one has a greater momentum? Which one is harder to stop? Definitely, the momentum of the truck is greater than the momentum of the car. Why is that? Because the momentum is directly proportional to the mass. If the mass increases, this means that the momentum will increase. Similar thing here. If we want to calculate the momentum of this bicycle having mass 50 kilograms and moving with velocity 60 meters per second, it will be 50 kilograms multiplied by 60 meters per second. This is equivalent to 3,000 kilogram meters per second or 3,000 Newton second. What about the momentum of a truck having a mass of 2,500 kilograms and moving at the same velocity? Before calculation, we are sure that the momentum of the truck is greater than the momentum caused by the bicycle because the truck has a greater mass. 2,500 kilograms multiplied by 60, this is going to give us a momentum of 150,000 Newton second or kilogram meter per second. So the momentum is directly proportional to the mass of the body, and the momentum is directly proportional to its velocity as well. Now we want to talk about another physical quantity related to the momentum, which is the change in the momentum of the object. I have a car of mass 300 kilograms. This car is moving with a velocity 2 meters per second. This is its initial velocity. This car has accelerated to reach a velocity of 5 meters per second. I want to calculate the change in its momentum. Change in momentum means the difference between the final momentum and the initial momentum. We can calculate it from the final momentum minus the initial momentum. Final momentum means the mass multiplied by final velocity minus initial momentum, the mass multiplied by initial velocity. The mass of the body 3000 kilograms. Its final velocity is 5 meters per second minus 3000 kilograms multiplied by 2 meters per second, which means that the change in momentum is 15,000 minus 6,000, the initial momentum. The momentum has changed by 9,000 meters per second. Of course, some of you might look and say, the mass has not changed during the motion. The mass was constant. Why don't we make life easier by taking the mass as a common factor? We can calculate the momentum by taking the mass as a common factor, and we multiply the mass by the change in velocity. In this case, the 3000 kilogram will be multiplied by final velocity, which is 5 meters per second, minus initial velocity, which is 2 meters per second. يبقى 3000 kilograms multiplied by 3 meters per second. This is equal to 9,000 kilogram meters per second. This is another way for calculation the change of momentum. Now let's have a look at a different example for the change in momentum. I have a ball of mass 3 kilograms that hit the wall with initial velocity 5 meters per second, and it rebounded back with final velocity v 2 meters per second. Question number 1, calculate the change in velocity. Change in velocity means final velocity minus initial velocity. The final velocity is 2 and the initial is 5. Is this accurate? No, it's not. Why it's not accurate? Because if I'm going to assume that this is my positive direction, this is just an assumption. I'll assume that this direction is positive, يبقى velocity has got a positive sign. The final velocity has got a positive sign, and the initial velocity, which is going to the right, must be given a negative sign. يبقى هاجي هنا واحط negative sign. And in this case, the change in velocity will be minus 5. الماينس موجودة في الرول تنزل زي ما هي minus 2. يبقى ال change in velocity is negative 7 meters per second. طيب, you might say, I don't like to assume the positive direction as the left, the direction to the left. I'll assume that this is the positive direction. If you assume that this is the positive, this means that the initial velocity is positive and the final velocity is negative. Would this make any difference to my answer? لا, هنا I substituted في first one ب V مكان U. Okay, I'll do it again. هنا final velocity in this case V minus U, يبقى negative 2 minus U اللي هي given 5, يبقى negative 7 meters per second. طب let's assume that the positive direction is in the opposite direction to this one. I'll assume that this is my positive direction. If this is my positive direction, going to the left is assumed to be the positive, then the V will take a positive sign and the U will be given a negative sign عشان ده عكس البوزيتيف اللي انا افترضته. يبقى ممكن احسبها دلتا V equal V minus U اللي هي 2 minus negative 5. This is going to make the change in velocity 7 meters per second. It's the same value. Both are correct. It makes no difference whether it has got a negative sign or positive sign, because this depends on my assumption of the positive direction. But what about the mass, the change in momentum? The change in momentum is equal to mass multiplied by the change in velocity. For some of you who used this first method, they assume that the positive is going to the right. they are going to get the change in momentum 3 times negative 7, which is equal to negative 21 kilogram meters per second. And those who assumed the left as positive, they would get the answer 3 times 7, which is equal to 21 kilogram meters per second. Both have got the same answer for the momentum. Does the negative sign here has any effect on my answer? No, because it's just the assumption of the positive direction. Okay? Now, if I have a ball moving with constant speed of 4 meters per second in a circle, is this ball having a constant momentum or a changing momentum? Yes, this is correct. If the direction changes, then the velocity changes and the momentum will change. This ball has got a changing momentum because as direction changes, velocity changes and momentum changes. Now we are going to talk about another physical quantity that is so closely related to the momentum, which is the impulse. What is the impulse? In order to get a body to experience a change in momentum, this body needs a force that acts on the body for a time interval. Let's see this example. This is a car having a mass of 200 kilograms moving at 6 meters per second. If I have to get the car to stop, to reach 0 meters per second, then this car is going to experience a change in momentum equal mass times the change in velocity. The mass is 200 kilograms. This will be multiplied by 0 minus 6. The change in momentum is negative 1,200 kilogram meters per second. How can I make a car moving at 6 meters per second, a car having mass 200 kilograms, how can I get it to stop? I have to apply a big force on the car to cause it to stop, a force that will act on the car for unit interval. It's either I'm applying the brakes for a long time, or maybe this car had an accident and it stopped in fractions of a second. In all cases, to cause this change in momentum, which is equal to 1,200 kilogram meters per second, I need a force that will act on the object for a time interval to cause this change in momentum. يبقى الإمبulse هو نفسه الchange in momentum. الforce multiplied by the time for which it was acting is equal to the change in momentum. يبقى for this body which has experienced a change in momentum for 1,200 kilogram meters per second, it was affected by a force that acted for a time interval on it, causing a change in momentum equal 1,200. This might be caused, this change in momentum of 1,200 kilogram meters per second might be caused by a force of 1,200 Newton acting for a time interval 1 second, or a force of 120,000 Newton acting for a time interval 0.01 seconds. In all cases, whether I use this big force, this small force, acting for a long time interval 1 second to cause a change in momentum of 1,200, or a bigger force of 120,000 Newton acting for a time interval of 0.01 second, in all cases the car has experienced the same change in momentum, which is equal to the force acting on it multiplied by the time. Same idea here. If a person falls from a building, this person accelerated as he falls and he reached the ground at 5 meters per second. When he hit the ground, his speed has become 0 meters per second. He has experienced a big change in momentum equal to what? Equal to his mass multiplied by the change in velocity. What is the change in velocity in this case? 60 kilograms. The final velocity is 0. His initial velocity is -5. He has experienced a change in momentum equal 300 kilogram meters per second. طيب, if I know the stopping time, can I know the force that acted on this man or on this person who fell from a building? Yes, because the impulse, the force multiplied by the time for which it acted on the body is exactly equal to the change in momentum that has happened. If the stopping time here is 0.01 second, this is the stopping time. It means that this person was affected by a force equal how many newtons? I'm going to divide both sides by 0.01 seconds. This means that this person was affected by a very big force of 30 kilonewton or 30,000 newton, causing him to be badly injured. Because to cause this change in momentum, a big force acted on him for a short time. He experienced a very big change in momentum in a very short time. Okay? If this person, when he fell, he was lucky enough to find the mattress behind him. So he kept moving up and down until he stopped. He took stopping time 3 seconds. Is he going to experience the same force? No. The force will be much less than the first force that acted on him when the stopping time was very short, when it was 0.01 second. Did he experience the same change in momentum? Yes, he was falling with 5 meters per second and he stopped all of a sudden. So he has experienced a change in momentum equal -300 kilogram meters per second. Why is the force less this time? Because the stopping time was much greater. The impulse is equal to the change in momentum. يبقى الforce multiplied by the time, the force that I don't know yet, multiplied by 3 seconds is equal to -300 kilogram meters per second. Meaning that the force that he was affected by was only -100 Newton. So it's much less. Okay? But we now must be sure of the relation between the impulse and the momentum, the change in momentum. The impulse, which is equal to the force multiplied by the time for which it was in contact with the body or it was acting on the body, is exactly equal to the change in momentum that will happen to this object. Now, as you can see, if I know the change in momentum and I know the time for which the force was acting, I can calculate the force. I can divide both sides by the time, which means that the force is equal to the change in momentum over time. يبقى الchange in momentum over time هو نفسه equal to the force, which means that the force is equal to the rate of change in momentum. And please study. This is the definition of force that you're supposed to know. يبقى force is equal to the rate of change in momentum. It's equal to the change in momentum divided by the time. That's why in all types of vehicles, people designing the cars or any different type of vehicle are concerned about the safety measures that they are using. Okay? So they are trying to increase the stopping time in order to decrease the force acting on the body. How can we increase the stopping time of the passenger found inside the car or a vehicle? By using seat belt, airbags, the crumple zone found in front of the car. All these things are going to increase the stopping time, and this is going to decrease the force, because when the change in momentum is constant, the force and the stopping time are inversely proportional. Now we will talk about the principle of conservation of momentum. Principle of conservation of momentum states that in any isolated system, which means in absence of an external force, the total momentum of an object before collision is exactly equal to the total momentum after collision. Okay, so the principle of conservation of momentum means that in any isolated system, without the interference of any external force, the total momentum of the whole system before collision is equal to the total momentum before collision. So if I have two objects, A and B, and they were moving, after collision, maybe A has accelerated and B has decelerated, maybe A has stopped and B has continued moving. In all cases, regardless what has happened after collision, the total momentum of A and B before collision is equal to the total momentum of A and B before collision, meaning that mass of A multiplied by its initial velocity plus mass of B multiplied by its initial velocity must be equal to the mass of A multiplied by final velocity plus the mass of B multiplied by its final velocity. What's the reason and what's the proof for the principle of the law of conservation of momentum? The reason is that the momentum lost by an object or a body during the collision will be equal to the momentum gained by the other object. So after all, the total momentum of the two bodies before collision is equal to the total momentum after collision. Now let's have a look at this question. I have a green car that is at rest and a blue car that is moving with 5 meters per second. The mass of the green car is 200 kilograms and that of the blue car is 300 kilograms. When they collided, the green car has moved forward with 1.5 meters per second. What will be the new velocity of the blue car after collision? By applying the law of conservation of momentum, momentum of the green car multiplied by its initial velocity plus the momentum of the blue car multiplied by its initial velocity equal mass of the green car times final velocity plus the mass of the blue car times its final velocity. So let's substitute the mass of the green car 200. It was stationary, so zero momentum before collision. The mass of the blue car is 300, was moving with 5 meters per second. This is equal to the mass of the green car 200 multiplied by its new velocity 1.5 plus the mass of the blue car times VB. The mass of the blue car, let's substitute by its value, it's 300. Let's solve this equation mathematically. 0 plus 1500 equal 300 plus 300 VB. Subtract 300 from both sides, يبقى 1200 equal 300 VB. يبقى the final velocity of the blue car is equal to 4 meters per second. Okay? If you haven't noticed, the green car has gained momentum. It was moving, it was at rest, and it has gained momentum because it moved with final velocity 1.5 meters per second. The change in momentum or the gain in momentum for the green car is equal to 200 multiplied by 1.5, yani equal 300. It has gained momentum of 300 kilogram meters per second. What about the change in momentum for the blue car? It was moving with 5 meters per second and it's now moving with 4 meters per second. It has lost momentum. A loss in momentum is equal to 300 multiplied by 4 minus 5. It has lost a momentum of 300 kilogram meters per second. So this will help you more to explain how to understand the law of conservation of momentum. The blue car has lost momentum of 300 kilogram meters per second and the green car has gained momentum of 300 kilogram meters per second. Let's see another example. Here the green car is moving toward the left and the blue car is moving in the same direction towards the left. The green car has mass of 250 grams. The red one has mass of 400 kilograms. Before collision, the velocity of the green car was 2 meters per second and that of the blue car was 4 meters per second. After collision, they will stick together and move with a common velocity. So after they collided together, they both moved to the left with same velocity, common velocity. طب let's apply the law of conservation of momentum and we see if it will help us to solve the question. Mass of body A multiplied by its initial velocity plus the mass of body B multiplied by its initial velocity is equal to the momentum after collision. After collision, as if I have a new body having a mass of 650 kilograms اللي هو the momentum of أو the mass of both cars moving with final velocity of unknown value اللي هي common velocity. Let's substitute 250 times 2 plus 400 times 4. This will be equal to 250 plus 400 multiplied by their common velocity. يبقى 500 plus 1600 equal 650 V. 2100 equal 650 V. Our final velocity is equal to 2100 over 65 equals 3.2 meters per second. But this means that after collision, they will move together with a velocity of 3.2 meters per second. طيب, let's have a look at this third type of questions. I have a car A moving to the right. Okay, it has a mass of 200 kilograms and initial velocity 2 meters per second, and another car B having mass of 400 kilograms moving to the right, to the left with 4 meters per second. After collision, they both moved to the left, okay, with 2.5 meters, after collision, the blue car moved to the right and to the left with 2.5 meters per second, and the green car moved again to the left with unknown velocity. What will be the velocity of the green car after collision? أنا هنا عندي the green car was moving to the right, the red car was moving to the left. After collision, they both moved to the left. Okay, the red car moved with 2.5 meters per second, and I want to know the velocity of the green car. Here, I have to assume a positive direction. I can choose any direction that I would like and assume as positive. For myself, I might prefer to assume the left as positive because the majority of the velocities are to the left. يبقى all cars going to the left, I'm going to put beside their velocity a positive sign. Positive sign. The only one that has a negative sign, the green car which was going to the right before collision. And I'm going to apply the rule. MA, initial velocity of A, plus mass B multiplied by initial velocity of B equal mass A multiplied by its final velocity plus mass of B multiplied by its final velocity. Mass of A 200, it was moving with negative 2 meters per second because it's moving in direction opposite to my positive that I assumed, plus mass B 400 kilograms multiplied by 4, it's moving in my positive direction, equal the mass of A multiplied by its final velocity that is still unknown. I'm going to write the mass of A, which is 200, plus the mass of B, which is 400, multiplied by its final velocity, which is going again to the left with a positive sign, 2.5. the physics part is over. Negative 800 plus 1600 equal 200 VA plus 1000. طيب هنا I have to subtract this. يبقى 800 equal 200 V plus 1000. يبقى هنا VA 200 VA equals 800 minus 1000 equal negative 200. يبقى VA equals negative 1 meter per second square. Okay. There is a mistake in calculation. Let's calculate this again. Negative 400 plus 1600 equal 200 V plus 1000. 1200 equal 200 V plus 1000. 1000 will go to the other side by subtraction. يبقى 200 equal 200 V. And final velocity equal 1 meter per second. دي الفاينل velocity بتاعت الجرين car. Okay. Now in this PDF you can solve extra examples and there will be a sheet that will be sent in the class. That's all.